The amazing engineering of an aircraft. A lot of us loves aircraft. Also, aircrafts is one of the most valuable transportation in the whole world. So, we will discuss today what was the main components and how an aircraft fly, so let's jump into the discussion. Any fixed-wing aircraft that is heavier than air, driven by a high-speed jet or screw propeller, and supported by the air's dynamic reaction against its wings is referred to as an airplane. See the history of flying for a description of the creation of the airplane and the beginning of civil aviation. An airplane's movable surfaces manage the plane's attitude. While in flight, its tail surfaces stabilize the wings, its wing system keeps it in the air, and its power plant generates the thrust required to propel the vehicle through the air. The aircraft needs to be supported during takeoff and landing, as well as while it is at rest on the ground. The majority of aircraft have the cockpit is where the pilot uses the controls and instruments to fly the aircraft. The fuselage is the enclosed body that houses the crew, passengers, and cargo. There are 4 forces operating on an airplane. During straight and level, unaccelerated flight, more forces are involved while turning, diving, or rising in flight. These forces are lift, which acts upward, drag, which acts as a retarder due to resistance to lift and to the aircraft's friction as it moves through the air, weight, which acts downward, and thrust, which acts forward due to the propulsion system or, in the case of an unpowered aircraft, by using gravity to translate altitude into speed. Weight and drag are characteristics that are present in everything, including airplanes. Artificially generated lift and propulsion are components designed to allow an aircraft to fly. And grasp of an airfoil. A structure made to receive reaction from the air it travels through is necessary before attempting to comprehend lift. Typically, the only features of early airfoils were a flat undersurface and a gently curved upper surface. Airfoils have been modified over time to accommodate evolving requirements. By the 1920s, airfoils usually featured a rounded upper surface, with the first third of the chord width reaching the highest height. The thickest portion of the airfoil progressively drifted backward, while the upper and lower surfaces curled to varying degrees over time. The laminar flow airfoil, where the camber was further back than modern practice required, was able to generate the extremely smooth airflow across the surface that was required as air speeds increased. Even more radical modifications to airfoil designs were needed for supersonic aircraft. Some of them lost their traditional round shape and developed double wedge shapes instead. The wing's airfoil moves forward in the air, causing the air flowing over its surface to react in a way that is helpful for flight. In flight, the airfoil of the wing normally produces the greatest amount of lift, but propellers, tail surfaces, and the fuselage also function as airfoils and generate varying amounts of lift. In the 18th century, the Swiss mathematician Daniel Bernoulli discovered that if the velocity of air is increased over a certain point of an airfoil, the pressure of the air is decreased. Air flowing over the curved top surface of the wing's airfoil moves faster than the air flowing on the bottom surface, decreasing the pressure on top. The higher pressure from below pushes lifts the wing up to the lower pressure area. Simultaneously, the air flowing along the underside of the wing is deflected downward, providing a Newtonian equal and opposite reaction and contributing to the total lift. That's all for today. Hope you learned something. Please don't forget to subscribe and hit the like button. Thank you.